Good day, learners, and welcome to today's session on KMO6 KTO4, which focuses on procurement, raw materials, and inbound logistics. By the end of this session, you and I will have a practical understanding of 4 areas. 1. Production as conversion, how inputs become outputs and where supervisors influence flow. 2. Procurement, how I source the right materials with the right quality at the right cost and time. 3. Distribution and stores, how I control inventory and keep storage flowing safely and efficiently. 4. Inbound logistics, how receiving, inspection, and put away protects our schedule and quality. I will ground every idea in our manufacturing context so you can apply it on the floor immediately. Here is what I intend for you to walk away with. I want you to be able to explain production as conversion system in plain language, show how procurement choices affect cost, quality, and lead time, run stores with basic inventory controls, and design a simple, reliable inbound flow from receiving to line slide. I will make links to the formative and summative assessments so you can answer with confidence. With that destination set, I begin at the highest level. Production as conversion. Let's take a look. When I say production is a conversion system, I mean we transform inputs into outputs through a process. Inputs include materials, labor, machines, methods, environment, and information. The process is our sequence of operations from incoming inspection and preparation to fabrication, assembly, and test. The outputs are finished goods that meet specification, delivered safely, on time, and at cost. To manage conversion well, I clarify 3 things. 1. What value the customer expects: features, quality, delivery window, and price. 2. How we flow work: batch size, working process limits, changeover routines, maintenance, and quality checkpoints. 3. Which constraints control throughput: bottleneck, machines, supplier lead times, skills, or layout. I visualize the system as a simple map: supplier, inbound receiving, stores, kitting, line side, process steps, finished goods, and then customer. Make waste visible on this map: waiting, overproduction, defects, excess motion, overprocessing, transport, and inventory. Then I attack the constraints with practical actions. SMED, reduce changeovers; 5S, to stabilize workplaces; TPM, to increase availability; and standard work, to reduce variation. I also connect conversion to basic measures. Throughput tells me the pace at which conversion inputs into sellable output. Cycle time and lead time tell me how long conversion takes. First pass yield tells me how cleanly we convert without rework. Inventory tells me how much cash is tied up in the system. Together, these measures help me prioritize improvements. Before I leave the system view, I add a few practical tools. I calculate takt time as available production time divided by customer demand, and I balance work to meet their pace. I look for bottlenecks by measuring queue build-up, uptime, and changeover duration at each step. I raise availability with basic autonomous maintenance, and I schedule planned maintenance when demand is lowest. I stabilize work using standard work and visual controls so that variation is visible early. I connect flow and inventory using Little's Law, which reminds me that average work in process equals throughput multiplied by average lead time. If I want shorter lead time, I reduce queues or raise liable throughput. I monitor first pass yield, and I fix root causes at the station that creates the defects so that the quality is built in and not inspected in. I use simple control charts for critical dimensions so that I see drift before parts go out of spec. With the system view clear, I now move upstream to procurement because what I order and how I order sets the conditions for the whole conversion process. Let's take a look. In procurement, my goal is simple. Bring the right item from the right source, at the right quality, right cost, and right time. I manage 4 levers. 1. Source strategy. 2. Quality assurance. 3. Total cost. And 4. Lead time. Source strategy. I classify items by risk and spend. For strategic, high-risk items develop suppliers, secure dual sources where practical, and set clear performance expectations. For standard catalog parts, I leverage contracts and frame agreements. I clarify Incoterms where applicable so responsibilities for transport, risk, and customers are ambiguous. Quality assurance. I flow down specifications, drawings, and change control. For new or changed parts, I use structured onboarding, technical review, sample approval, and where relevant, PPAP, or first article inspection. I agree on reaction plans for non-conformance and require corrective action with clear due dates. I keep incoming inspection data and share trends with suppliers so we solve problems at the source. Total cost. I look beyond unit price. I include transport, duties, packaging, ordering, costs, minimum order quantities, yield losses, and line stop risk. I challenge packaging that creates waste, and I negotiate replenishment terms that reduce our inventory without starving the line. Lead time. I map supplier lead time into our master schedule. I reduce lead time using 3 practical moves. 1. Place forecast orders for long lead items with call-offs. 2. Standardize parts to increase flexibility and locate inventory closer to use, either vendor-managed inventory at our sites or local buffer for critical items. I do not push risk blindly to suppliers. I collaborate so both sides can deliver on time. Operational discipline matters. I raise clear purchase requisitions, confirm purchase orders, track confirmations, and promise dates and escalate early when risk appears. I keep a supplier scorecard with quality, delivery, responsiveness, and cost, and I review it regularly to drive improvement. I also segment suppliers and items so that I supply the right strategy. I use a simple 2x2 view of risk and spend. Strategy and high-risk items get development plans, dual sourcing where feasible, and closer collaboration. Leverage items get competitive sourcing and contract discipline. For routine items, I simplify ordering with catalogs and blanket orders. I ask for cost breakdown so that I understand material, labor, overhead, tooling, and logistics. I prepare a should cost estimate to challenge quotes respectfully. I am explicit about Incoterms such as EXW, FCA, and DDP so that responsibility and risk are clear. I expect basic ethical conduct, no gifts that create obligation, no conflicts of interest, and transparent decisions recorded in a file. I track key supplier metrics such as on time in full, incoming defects per million, response time on corrective action, and price movements against an index. When quality issues occur, I expect an AD or equivalent corrective action with verified effectiveness. Once materials are on their way, I shift attention to distribution at stores, how I protect material, control inventory, and feed production reliably. Let's take a look. Stores exist to protect material condition and to make the right item available at the right place and time. We establish four foundations. 1. Identification. 2. Location. 3. Condition. And 4. Control. Let's begin with identification. Every item gets a unique part number, description, and unit of measure. I label shelves and bins clearly. I avoid look-alike parts living side by side. I apply barcodes or QR codes where possible so we can scan rather than transcribe. Moving on to location. I design storage with fast movers closest to issue points and heavy items at safe heights. I separate quarantine, returns, and non-conforming areas from good stock. I use first in, first out lanes for shelf life items. And now we move on to condition. I protect materials from moisture, dust, and damage with the right packaging, packing, and handling. I control ESD for electronics and temperature for sensitive goods. I train material handlers in safe use of equipment and correct stacking. Let's take a look at control. I choose a replenishment method that fits demand, 2-bin, can-bin, or min-max. I run cycle counts to verify accuracy and investigate variances quickly. I record receipts and issues in the system on the day so physical and system stock stay aligned. I keep safety stock only where variation or supply risk justifies it, and I review the levels quarterly. Distribution to internal customers depends on clarity. Publish store hours, cut-off times, and kitting rules. Kits with visual checks, and I lock kits once complete. For inter-site distribution, I plan dispatch windows, paperwork, and career performance, and I track on time in full. To control inventory, I apply a few simple calculations in plain language. I set an order point so that we reorder before we run out. The order point equals average demand during lead time plus a safety buffer for variability. I size safety stock between how much demand or lead time varies and on the service level we need for that item. I use ABC analysis so that I count high-value items more often and control them more tightly. I set cycle count frequency by class and I investigate any variance on the same day so that the ledger stays trusted. I manage slow-moving and obsolete stock by flagging items with no movement in a defined period, and I agree to disposition plan with engineering and finance. For hazardous or temperature-sensitive materials, I enforce storage rules, separation and signage, and I train handlers in spill response and safe lifting. I keep clear segregation of duties between requesting, receiving, issuing, and reconciling to reduce errors and fraud. Materials do not appear by magic. They arrive and must be processed cleanly. So now I detail inbound logistics, receiving, inspection, and put away. And now we are taking a look at inbound logistics, receiving, inspection, and put away. Let's start with receiving. I prepare before trucks arrive, bookings where needed, a clear receiving bay, calibrated scales, and working scanners. I check delivery notes against purchase orders, supplier, part number, quantity, lot or batch, or any certificates. I note visible damage and photograph if needed before offloading. I separate urgent items and fast-track them safely. Let's talk about inspection. I apply the right level of incoming inspection. For fully approved suppliers on stable parts, I may accept on certificates with spot checks. For new or risky parts, I follow an agreed sampling plan and verify critical dimensions or attributes. I record results, lot numbers, and expiry dates. Non-conforming materials goes to clearly marked quarantine area with a hold ticket, and I raise a non-conformance for disposition. And lastly, put away. I assign the correct location in the system before moving stock. I use standard routes and handling equipment to prevent damage. I scan to confirm bin and quantity, and I apply any secondary labels for line side identification. I close the receipts in the system only after physical put away is complete. Information flow is as important as material flow. I notify planners when receipts are clear. I alert quality and engineering if a trend is developing. And I inform suppliers early when defects or shortages occur. Clean receiving, inspection, and put away prevent downstream chaos. I also tighten the receiving process with information flow. I request an advance shipping notice so I can plan docks, people, and space. At the dock, I measure dock to stock time and I remove causes of delay such as printer downtime, missing locations, or unclear quarantine. I agree on acceptance sampling approach for new parts so that we escalate inspection and then relax to skip lots as performance proves capable. I require lots and expiry capture for anything with shelf life, and I print internal labels that match line side picking to prevent selection errors. I close the loop with suppliers by sending defect evidence quickly and by requesting permanent corrective action when trends appear. To knit these topics together, I now run a practical end-to-end example that we can use in our plants. Let's take a look. Let's begin with context. We introduce a new seal material for a pump assembly. It is safety critical and has 12-week supplier lead time and a 6-month shelf life. Let's take a look at procurement. I classify the seal as strategic. I see specifications, drawings, and change control. I place a forecast undercovering 3 months of demand with monthly call-offs and a vendor-managed buffer of 2 weeks on site. I negotiate moisture barrier packaging to reduce damage, and I agree on containment plan for the first 2 lots. Inbound logistics. I pre-book receiving slots. On arrival, I check packaging integrity, verify lot and expiry, and fast-track the lot to incoming inspection. I sample per plan, verify critical dimensions and hardness, and record results. Non-conformances, if any, go to quarantine, otherwise are released for put away. Let's move on to stores. I assign a control temperature bin, label with part, lot, and expiry, and set IFO lines. I configure a 2-bin can ban size of 2 days of usage with a minimum of 1 day as safety. I add the seal to a kitting checklist for the pump line. Production as conversion. I train operators on handling and traceability. I verify first part yield and monitor scrap for the first 3 weeks. I review throughput weekly to confirm the buffer and can ban sizes are correct. If demand rises, I adjust call-offs and recalculate safety stock. Let's discuss outcomes. The line avoids stockouts, scrap drops due to better handling, and cash exposure is controlled through the buffer and can ban sizing. This shows how procurement, stores, and inbound logistics directly support conversion. Additional numeric check. I revisit the buffer using a simple 2-card can ban sizing. I take average daily demand, multiply by replenishment lead time in days, add a small safety factor for variability, and divide by the standard pack size. I round up to the nearest whole card so that handling is simple for operators. I then verify that the order cycle and transport frequency can support the number of cards without starving or overfilling the line. I now connect today's content to your assessments and to the exact outcomes we targeted. Let's take a look. Summative questions ask you to discuss and explain production as conversion, procurement and distribution, stores and inbound logistics. In your answers, use plain language, define the key terms, give one plant example, and show at least one control or metric you would use. For formative tasks, be ready to define production as conversion, list procurement, such as price, provenance, and performance. Propose strategies to manage lead time and explain how inbound logistics improves competitiveness by protecting quality and schedule. A strong response follows this pattern. First define the concept, then show the method or process you would run. Let us finish by recapping the journey and committing to the first steps on the shop floor. We have now reached the end of our session. Today we built a practical map of procurement, raw materials, and inbound logistics. We described production as a conversion system and identified the constraints we have and can influence. We showed how procurement choices shape quality, cost, and lead time. We established storekeeping fundamentals for identification, location, condition, and control. We detailed inbound logistics from receiving through inspection to put away, with information flow to match. We leave with a repeatable candidates we run every day. My ask for the next shift is simple. Choose one material flow into your area. Map its current path from receiving to line side, mark the delays and errors, and propose one change you can implement within a week. Perhaps a Kanban card, a clearer label, or a quicker receipt to put away loop. Bring the result to our next forum and we can learn together and improve. Thank you for your attention and participation today. See you at the next session.